How are you doing today? Alright, I hope we are all in good health, happy, and always excited about all activities. In the previous video, I have explained the topic about circles. Now, let's see what we are going to learn today. Okay, without further ado, on this occasion, I will share and explain the material about quadratic equation and function. Does anyone know what quadratic equation and function are like? Let's check it out. But before that, let me introduce myself. My name is Komang Trisna Jayanti with student ID number 2113011-021 from class 40 of Mathematics Education. I hope you can enjoy watching my video with great excitement. To begin our discussion, let's take a look at this slide. There are two topics of discussion that we will discuss today. First, the definition and basic form of quadratic equation and function. Then, the second is the solution and examples of quadratic equation and function. As we dive into the topic of quadratic equations, let's first understand the concept of quadratic polynomial. A quadratic polynomial is a polynomial of degree 2, which means the highest power of the variable is 2. Its basic form can be represented as ax squared plus bx plus c, where a, b, and c are coefficients and a is not equal to 0. Now, let me ask you a question. Can anyone tell me what makes a quadratic polynomial different from a quadratic equation? Take a moment to think about it. Well, the answer lies in their nature. A quadratic polynomial is an algebraic expression, whereas a quadratic equation is an equation that sets the quadratic polynomial equals to 0. In other words, when we say the quadratic polynomial equals to 0, we have a quadratic equation. Now that we have a clear understanding of these terms, let's move forward and explore how to solve quadratic equations. Now, let's delve into the concept of quadratic equations. A quadratic equation is an equation that can be written in the form of ax squared plus bx plus c equals 0, where a, b, and c are coefficients and a is not equal to 0. This is known as the basic form of a quadratic equation. Here's an example to illustrate this. Consider the equation x squared plus 3x plus 9 equals 0. Now, I'd like to ask you directly, can you determine the values of a, b, and c in this equation? Take a moment to think about it. Correct. The coefficient of x squared is 1, so we have a equals 1. The coefficient of x is 3, so we have b equals 3. Lastly, the constant term is 9, so we have c equals 9. It's important to note that in a quadratic equation, a, b, and c can be any real numbers. These coefficients play a significant role in determining the behavior and characteristic of the quadratic equation. Now, let's move on to discussing the solution of quadratic equations. There are three common methods to solve quadratic equations. First, factoring quadratic. This method involves factoring the quadratic equation into two binomial expressions and setting each factor equals to 0. By solving for the values of x that make each factor 0, we can find the solution of the quadratic equation. Second, completing the square. In this method, we manipulate the quadratic equation to create a perfect square trinomial. By adding or subtracting a constant term, we can transform the equation into a square of a binomial. Then, we solve for x by taking the square root of both sides of the equation. And third, quadratic formula. The quadratic formula is a general formula that gives us the solution of any quadratic equation in the form ax squared plus bx plus c equals 0. It states that the solution, denoted as x, can be found using the formula x equals negative b plus minus square root of b squared minus 4ac over 2a. Now, let's illustrate an example of the first method, factoring quadratic. Factoring involves finding the factors of the quadratic equation. Let's consider the quadratic equation x squared plus 3x plus 2 equals 0 as an example. To factor this quadratic equation, we need to find two numbers. Let's call them x1 and x2. Whose sum is 3 or the coefficient of x and whose product is 2 or the constant term. In this case, x1 equals 1 and x2 equals 2. We can express the quadratic equation as x plus x1 times x plus x2 equals 0 by using the factor form. Substituting the values of x1 and x2, we have x plus 1 times x plus 2 equals 0. Now, let me ask you, what are the possible solutions or roots of this quadratic equation? Yes, good. The possible solutions or roots are x equals negative 1 or x equals negative 2. By factoring the quadratic equation, we have determined the values of x that make the equation equals to 0. In this case, x can be either negative 1 or negative 2. Now, let's discuss the concept of completing the square. This method allows us to rewrite a quadratic equation in a perfect square form, which makes it easier to solve. The general form of a quadratic equation is ax squared plus bx plus c equals 0. Completing the square involves transforming the quadratic equation into the form a times x plus b squared plus e equals 0. This form represents a perfect square trinomial, where the variable x is saved by a constant value or d and squared, multiplied by a coefficient a and added to another constant term e. This transformation allows us to simplify the equation and obtain its solutions more easily. Overall, completing the square is a valuable technique that not only simplifies the process of solving quadratic equations, but also provides deeper insight into the characteristic of the quadratic function represented by the equation. To complete the square, we can follow these steps. First, divide all term by a, or the coefficient of x squared. In this step, we divide each term in the quadratic equation by the coefficient a to bring the equation into the form of x squared plus b over a times x plus c over a equals 0. This is done to ensure that the coefficient of x squared is 1. Second, move the number term c over a to the right side of the equation. In this step, we move the number term c over a to the right side of the equation. So we have x squared plus b over ax equals minus c over a. Third, complete the square of the left side of the equation and balance this by adding the same values to the right side of the equation. This step involves completing the square on the expression x squared plus b over ax. To do this, we find a constant term, d secant x plus d squared equals x squared plus b over ax. Next, take the square root on both sides of the equation. In this step, we take the square root of both sides of the equation, so we obtain x plus d equals plus minus square root of negative c over a plus d squared. Last, add or subtract the number that remains on the left side of the equation to find x. By following these steps, we can transform the quadratic equation into a simple form and make it easier to solve. Now, let's explore an example problem using completing the square method. Pay attention to the following slide. Solve x squared plus 12x plus 32 equals 0. Does anyone know the first step we should take? That's correct. First, Move the number term c over a to the right side of the equation. So we can write it as follows. X squared plus 12x equals minus 32. Next, complete the square on the left side of the equation and balance this by adding the same value to the right side of the equation. X squared plus 12x plus 36 equals minus 32 plus 36. So x plus 6 squared equals 4. Next, take the square root on both sides of the equation. X plus 6 equals 12 minus 2. And fourth, subtract 6 from both sides. X plus 6 equals 2. So x equals 2 minus 6 and x equals minus 4, or x plus 6 is equals minus 2, x equals minus 2 minus 6 and 6 and x equals negative 8. So the solution are x equals negative 4 or x equals negative 8. Alright, that was pretty easy, right? Let's move on to the next method. The next method we'll discuss is the quadratic formula. This formula provides a direct way to solve quadratic equations by substituting the values of a, b, and c into the formula and performing the calculations. Let's take an example equation. 3x squared minus 10x minus 8 equals 0. The coefficient of this equation are a is 3, b is minus 10, and c is negative 8. The quadratic formula is as follows. X1, 2 equals minus b plus minus square root of b squared minus 4ac over 2a. Now, let's plug in the values of a, b, and c into the formula. X1, 2 equals minus negative 10 plus minus square root of negative 10 squared minus 4 times 2 times negative 8 over 2 times 3. So x1, 2 equals 10 plus minus square root of 100 plus 96 over 6. And then x1, 2 equals 10 plus minus square root of 196 over 6. x1, 2 equals 10 plus minus 14 over 6. Simplifying further, x1 equals 10 plus 14 over 6 is 4, or x2 equals 10 minus 14 over 6 equals negative 2 over 3. Therefore, the solution to the equation are x1 is 4 or x2 is negative 2 over 3. Let's discuss the concept of the discriminant and the nature of the roots in a quadratic equation. The general form of a quadratic equation is ax squared plus bx plus c equals 0. To find the roots of the quadratic equation, we use the quadratic formula. The quadratic formula is x equals negative b plus minus square root of b squared minus 4ac over 2a. In this formula, the term square root of b squared minus 4ac is known as the discriminant. The discriminant helps us determine the nature of the roots of the quadratic equation. If the discriminant is greater than 0, then the quadratic equation has two distinct real roots. This means that the equation intersects the x-axis at two different points. If the discriminant is equal to 0, then the quadratic equation has two equals real roots. This means that the equation touches the x-axis at a single point. If the discriminant is less than 0, then the quadratic equation has no real root. This means that the equation does not intersect or touch the x-axis. The roots of the equation will be complex or imaginary numbers. By analyzing the value of the discriminant, we can determine the nature of the roots of the quadratic equation and gain insight into how the equation behave geometrically. Now let's practice finding the discriminant and identifying the nature of the roots for the following quadratic equation. First, I have 4x squared plus 12x plus 9 equals 0. So we have A. The value of A is 4, the value of B is 12, and the value of C is 9. Using the formula B squared minus 4AC, we get B squared minus 4AC equals 12 squared minus 4 times 4 times 9 equals 144 minus 144. So we get is 0. Since the discriminant is 0, this indicates that there are to the second, we have x squared plus 5x plus 6 equals 0. Here, the value of A is 1, the value of B is 5, the value of C is 6. We calculating the discriminant. B squared minus 4AC equals 5 squared minus 4 times 1 times 6 equals 25 minus 24 equals 1. So, since the discriminant is 1 or positive, there are two distinct real roots. And last, we have 2x squared plus 5x plus 4 equals 0. For this equation, A equals 2, B equals 5, and C equals 4. Finding the discriminant, B squared minus 4AC equals 5 squared minus 4 times 2 times 4 equals 25 minus 32 is negative 7. Since the discriminant is negative 7, so there are no real roots. In conclusion, we have covered the main aspect of quadratic equations and their solutions. Here are the key points to remember. First, the basic form of a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are coefficients. The second, there are three different methods to find the solutions of a quadratic equation: factoring quadratic, completing the square, and quadratic formula. And last, the third, the discriminant. The discriminant, which is the expression inside the square root in the quadratic formula, helps us identify the nature of the roots of a quadratic equation. The discriminant is denoted as D. The three possible conditions are: if the discriminant is greater than 0, then there are two distinct real roots. If the discriminant is equal to 0, then there are two equal real roots. And if the discriminant is less than 0, then there are no real roots. Understanding these concepts and methods will greatly assist in solving quadratic equations and analyzing their solutions. So, in general, these are the conclusions regarding the topic we discussed today. Remember, quadratic equations are not only mathematically significant, but also have numerous real-world applications. They play a crucial role in fields such as physics, engineering, finance, and computer science. Mastering quadratic equations will enhance your problem-solving skills and open doors to a wide range of mathematical applications. Thank you for your attention. We hope this information has been valuable and will contribute to your understanding of quadratic equations. Okay, everyone, that's all for me. See you in the next educational video and goodbye.